Many students who think that they're not good at math actually are just missing the meaning of certain words and symbols. And so what I want to do in this podcast is cover some of the more common words and symbols that we'll be using every single day in class. There's no way to cover them all, but I'll hit a few here. The first symbols we want to hit are the symbols that represent the four basic operations of adding, subtracting, multiplying, and dividing. The symbols for adding and subtracting, there's just one symbol for each. The plus sign for adding, the minus sign for subtracting. We refer to an addition as a sum. We talk about the sum of A and B being A plus B, but we could also write it as B plus A because after all 5 plus 2 is 7, which is exactly the same as 2 plus 5. So it doesn't make any difference whether you call it A plus B or B plus A. We refer to it in English as A plus B or A increased by B or the total of A and B, something like that, that represents bringing the numbers together. For subtraction, again, very simple. You simply use the minus sign. We say the difference between A and B is A minus B, but notice this time I didn't give you the choice. I didn't say or B minus A. Because when you change the order in subtraction, you change the answer. 5 minus 2 is 3. 2 minus 5 is negative 3. They are not equal to each other. One is 3, one is negative 3. So you have to be very careful about order in subtraction. It is not commutative. We would refer to this in English as A minus B, or we could call it the difference between A and B, or we could call it B subtracted from A. When you see that phrase subtracted from, that means the first thing mentioned will go last when you write the minus sign. Now the trouble with these symbologies come in multiplication and division, because in multiplication and division, sometimes the symbol that represents multiplication or division is simply not present. Sometimes it is. Old school, A times B was written as AXB. But that's been kind of dropped in recent years because it's not clear whether that's A times B or whether that's A times X times B, because X is also very frequently used as a variable name. So in more modern times, we've dropped the X sign for multiplication and gone to a dot, and we say A dot B means A times B. But if I simply put in no symbol at all, like 3 parentheses B, there's no add, subtract, multiply, or divide sign, but it's a multiply. There's an invisible dot right in front of the parentheses. And similarly, when I write 3A, I don't say plus, minus, anything. I just say 3A, and again, that means 3 times A, and the dot has been left invisible. There are also invisible symbols that come about when you're doing division. The old school way to do division is A divided by B with that kind of divided by symbol. But you've also seen this one, A slant line B, or more commonly, A horizontal line, B on the bottom. All of those represent A divided by B. Now there's a trouble with that second symbol. Suppose I had 3 divided by 2x. Is the 3 divided by the 2, or is it divided by the whole 2x? Well, actually, from this symbolism, the 3 is only divided by the 2. This means 3 over 2 times x. And a lot of people don't understand that. They think they're bad at math. It's just the symbol they don't understand. Now, how would you write 3 over 2x with a slant line? Well, you'd put 3 slant line and then you'd put your 2x in a bracket, and that would put the whole 2x on the bottom instead of just the 2. And when you have a horizontal division line, there's also something not fully understood there. If I have, for example, x plus 3 over x minus 1, horizontal division line, some people don't understand that there's an implied parentheses around the top and parentheses around the bottom. We don't show those parentheses usually because we've got the horizontal division line to stand in their place. But if you try to go into a calculator with this kind of symbol, first off, you won't be able to write it. You'll have to write something like this. And the only thing that will get divided is the 3 divided by the x. So you need to understand that when you see a horizontal division line, there's an invisible bracket on the top and an invisible bracket on the bottom. That's some of those invisible signs that we talk about. Now, this invisibility sometimes leads to order of operations trouble. For example, I could have 5 minus 3 times 2x minus 1. And I've seen this on test papers interpreted as 2. 5 minus 3 is 2 times 2x minus 1, and the student will get 4x minus 2. Well, that's not correct. There's an invisible times sign right here. And in the order of operation, times comes before subtraction. So you have to do the negative 3 times the 2x minus 1 first. So you get 5 times negative 6x plus 3, which gives you 8 minus 6x, not 4x minus 2. So be aware, a number beside a bracket means times. Times comes before adding or subtracting. So you can't do this part first. You have to do this multiplication first. Now, as far as frequently used words that we're going to use every single day in class this year, 2 of the most important are the word term and factor. A term is a product, a multiplication of numbers, variables, and or grouping symbols. So for instance, 3 is a term because it's a product of numbers, 3 times 1. 3x is a term because it's the product of a number and a variable. 3x times the bracket 2x plus 1 is a product of numbers 3, variables x, and grouping symbol the bracket. So that is a term. And this last one, which doesn't look like a product of a number and a grouping symbol, really is a product of a number and the grouping symbol. It's exactly the same as the number 1/5 times the grouping symbol 2x minus 1. Both of those are the same thing. Now, sometimes you're going to see multiple terms in a mathematical expression. For example, if I put a plus sign here and a minus sign here and an equal sign here, our definition of terms says terms are usually separated by plus, minus, or equal signs. So this plus sign is dividing these first expressions into 2 separate terms. The minus sign says that the 3x is a separate term from 3x bracket, and the equal sign says negative 3x bracket is a separate term from 2x minus 1 over 5. So if we look at this as an equation, this is an equation with 1, 2, 3, 4 terms in that equation. So if you're doing something to every term, like multiplying every term by 5, you would have to do that 4 times because you have 4 terms. Let's move on now to the last really critical word, one that we use every day. It's called factor. A factor is a part of a term. So here is a term, 2xy. What are its factors? Well, it's a part of a term which is multiplied by the rest of the term. So 1 is a factor because 1 multiplies everything. So 1 is multiplying the rest of the term, so it's a factor. 2 is a factor because 2 is multiplying the xy, so it's multiplying the rest of the term. X is a factor. It's multiplying the 2 and the y, so it's multiplying the rest of the term. Down the list of ways, xy is a factor because xy is multiplying the 2. And 2xy is a factor because it's multiplying the 1. Now contrast example 1 with example 2. Example 2, 2 times the bracket x plus y. Are the factors 2, x, y, etc. as they were above? Well, no, they're not. 1 is still a factor because 1 multiplies everything. 2 is a factor because 2 multiplies the bracket, and that's the rest of the term. The bracket is a factor because the bracket multiplies the 2, and that's the rest of the term. But the x is not a factor because while the x does multiply the 2, this gives you 2x, The x does not multiply the y. It is only added to the y. So x is not multiplying the rest of the term, therefore it is not a factor. Same for y. Y is multiplying the 2, but it is not multiplying the x. It's added to the x, so y is not a factor of this second term. Now let's go to the last part of this podcast, which is called the canceling rule. The canceling rule states as follows. In a fraction or in a product of fractions, if you have all multiplication in the numerator or numerators of the fractions, and all multiplication in the denominator or denominators of the fractions, you may cancel identical factors. Cancel identical factors. 1 for 1. You can't cancel 1x on the top with 2x's on the bottom. It's 1 for 1, and it has to be top to bottom. You can't cancel a 3 in this part of a fraction. You can't cancel the 3 here with the 3 that's not very clear. If you had a fraction like this, you can't cancel the 3 with the 3. That's not top to bottom, that's top to top, so that would not be okay. So let's take a look at this, and let's see how you would cancel with the expressions below. In the first one, you can think of the top as 2 times 2 times 3, because that's what 12 is, x times x, because that's what x squared is, and y. And on the bottom, you can think of it as 3 times y times y times y. Now we're allowed to cancel identical factors. So the 3 can cancel the 3, but it can't cancel a 2. The y on the top can cancel one of the y's on the bottom, and that leaves 2 x's on the top that did not get canceled, 2 x's on the bottom that did not get canceled. So we end up with 4x squared over y. We cancel the 3 over y squared. Now we don't normally rewrite this to look for things that cancel. We just kind of use our common sense and say, well, there's a 3 in the 12, so the 3 cancels the 3, and that would leave a 4, because 12 is 3 times 4. And there's 1 y on the top, and there's 3 of them on the bottom, and the canceling is 1 for 1, so I'll only cancel one of those y's, so there'll still be 2 y's on the bottom, and you end up with 4x squared over y squared. Now in the second example, a little bit different case. There's 2 possibilities for canceling. You can think of canceling the 2x with the 6x, and you can think of canceling the 3x with the 6x. The bracket here means that we are thinking of the 3x plus 1 as a single number called bracket. So the top is 2 times x times bracket, and the bottom is 6x. So we can cancel the 2 on the top with the 2 on the bottom and get a 3. We can cancel the x on the top with the x on the bottom and get 1s in both cases. And what we're left with is 3x plus 1 over 3. What we cannot do in this case is we cannot cancel the 3x with the 6x, because the bracket means all of the 3x plus 1 together is a single number. In other words, if you go in the bracket, you do not have all multiplication top, you have adding on the top. And the rule says you must have all multiplication, top and bottom. So as long as I stay out of this bracket, I can cancel. If I try to go into that bracket, I cannot cancel. Now in the next one, I can't cancel at all, because I just don't have all multiplication on the top. And that's one of the requirements for the canceling rule. So I'm not even allowed to attempt to cancel here. I just have to leave this just as it is. This is already simplified. In the last one, I can cancel, and you can say, well, why? You have a minus on the bottom. Well, because remember earlier we said that when there's a horizontal division line, there may be symbols missing. There's an automatic bracket that's invisible around the bottom. So the top is 3 bracket, the bottom is 1 understood bracket. So that's all multiplication top and bottom as long as I don't try to get inside of that grouping symbol. So I cancel the whole grouping symbol with the whole grouping symbol and I get a 3. Now that would be very different than if I tried to cancel like this, which I see very frequently on tests. Students will say, well, I'll cancel the x with the x and the y with the y. You can't. There's a minus on top. You can cancel a bracket with a bracket, but you can't cancel around a minus sign. And even if you could, what would you end up with? Well, since you replace them with ones, you'd have 1 minus 1 over 1 minus 1. That would be 0 over 0, and that is undefined. In math, you can't divide by 0, so that is a meaningless. If you try to use this on a test paper, that is meaningless in math. It has no meaning at all, and I will count it wrong. So when you're canceling brackets, cancel a whole bracket, as I did in this example. Whole bracket on top with whole bracket on the bottom, and that completes our podcasts on terminology.